Hello class, in this lesson we're going to be learning how to divide polynomials. And the reason we divide polynomials is in order to factor them. We're going to be looking at two different ways of dividing. One is with long division. You can use this on any sort of polynomial. And then synthetic division, which is easier but is limited in kind of the types that you can do. Okay, let's go back to numbers first before we even start looking at division really. Is 9 a factor of 24? No, it's not. If we do some division here, I'm actually going to show it with long division. We took 9 divided by 24. We figured out that 2 can, 2 times 9 is 18, and we get a remainder of 6. 6 is no longer divisible by 9, and we get this non-zero remainder, and because of that, we say 9 is not a factor. The remainder is not 0. Is 6 a factor of 24? Yes, it is. 26 divided by, or 24 divided by 6 is 4. The remainder is 0. That's the key thing. Therefore, 6 is a factor of 24. Same thing with polynomials. This word factor is used in the same idea, same kind of way. Is x minus 2 a factor of this polynomial? The key question is, let's check. Let's divide these two. Now, if we divide these two, I'm not going to, I'll be talking about more how this actually works in just a second. But in this case here, when we do the long division of this, we get down here, and we get 16 here. 16 cannot be divided by x minus 2. And so we get a remainder. The remainder is 16. We put that right up here. Again, because the remainder is non-zero, we say x minus 2 is not a factor. If we had a nice clean 0 remainder, it would be. And so the idea of this factor is kind of the same whether we're talking about numbers or whether we're talking about polynomials. Let's look at how to divide in more detail now. We're going to divide this polynomial, this degree 4 by degree 2 polynomial right here. And I'm going to set it up with long division right here. First step, I'm going to take the highest term right here divided by the highest term in my divisor. 2x to the 4th divided by x squared divides to 2x squared. I'm going to take that and put that right up there. Now I'm going to multiply 2x squared times this whole polynomial here. Gets me this. So, and this is kind of what we did when we had numbers. We multiplied these out. And then after that, we subtract. Make sure you subtract carefully. X cubed minus 4x cubed is negative 3x cubed. Subtract, subtract, subtract all the way down. Next step, we repeat this process. Now I'm taking negative 3x cubed, dividing that by x squared. So I'll just kind of write that over here as my little thought experiment. Negative 3x cubed divided by x squared, that's negative 3x. I write that up there. And that's also, then I also do the same thing. I take negative 3x, multiply it by this whole polynomial over here, and I get these three terms. Negative 3x times x squared, negative 3x times 2x, negative 3x times negative 1. Again, I subtract. And, conveniently, always the highest term disappears because that's what we did over here. We kind of structured it. We created it so the highest term will always disappear. Now I'm left with this. Repeat one more time. Take the 8x squared divided by x squared here. Kind of write that out over here. Bring the 8 right up there. And do a subtraction again. Now at this point, I'm done. Minus 18x divided by x squared, I can't do that, and so this is my remainder. I have my quotient on top, my remainder on bottom, and I could write out the long division here as my quotient plus my remainder piece divided by my divisor right here. So, non-zero remainder, not a factor. This polynomial down here is not a factor of the top. Now, that was long division. Synthetic division is a little easier way of doing it. of dividing, but it only works for very simple polynomials, degree 1 polynomials to be specific. When it's of the form x minus k, we can do what's called synthetic division. So here it is. We have this big polynomial up here divided by a very simple degree 1 x plus 3, which we could think of as x minus negative 3. So in this case, k is equal to negative 3. So this is the way we set it up. We take each of the coefficients, starting from the x cubed term, the highest, all the way down. So we have 2, 1, negative 8, and 5 that we just bring right down here. If there were a missing x squared term, for example, if this were not there, we would have to put 0 here. We don't just skip it. If we did not have a constant term at the very end, for example, we would put a 0 here as well. That's very important. That's the most common mistake when you miss that. Okay, then take the x plus 3 and you flip it. Okay, flip the sign. The 3 becomes a negative 3. Remember, it's x minus k, and so in this case, the k here is negative 3. So the process works like this. You take the 2, we add straight down. 2 plus nothing is 2. Now we multiply. Negative 3 times 2, we write negative 6 right up there. Add straight down. 1 and negative 6 is negative 5. Multiply up here. Negative 3 times negative 5 is 15. Add down. Multiply up. Add down. Now we're done. Now each of these numbers here are very important. They have very special meaning. The first 3 terms are the coefficients of our quotient. These 3 terms here. The next 3, the last term here, minus 16, is our remainder from the division process. Okay, so what I mean by the quotient, the coefficients of the quotient, is as follows. We started with an x cubed term, and we divided it by x, so the quotient is going to be 1 degree less. It's going to be x squared instead of x third. So each of these numbers here correspond to the coefficients of the quotient. So I just bring the 2x squared, minus 5x plus 7. Again, if any of these are 0, it just means that we have a 0 in any one of these places here. The negative 16 is our remainder, and so it's like minus 16 over x plus 3, where x plus 3 was our divisor. Non-zero remainder, x plus 3, therefore, is not a factor. Okay, so try this one out. I'll show the answer in 3, 2, 1. Okay, so here's the answer. We set up our k value is 4, drop in the coefficients, run through the synthetic division. We get 0 at the end. That means that it divided in perfectly, therefore x minus 4 is a factor. So yes, we could say it is a factor of the polynomial over here. And so this is our quotient, and we could actually even factor the quotient one more time into x minus 3, x plus 1, and this actually then tells us we have all the roots, or all the zeros, identified. We have a 0 at 3 because of the x minus 3. We have a 0 at negative 1 because of the x plus 1 factor, and also we have a 0 at 4 because of our x minus 4 factor that we found out was indeed a factor. So we have all the zeros right here. Let's do one more step. We can actually sketch out a graph for this. X to the third is odd degree. It's going to behave kind of like a line in terms of the end behavior. It has a positive coefficient, so the end behavior is going to be something like this. And now we can connect up the dots, and it'll be something roughly like that. That's the power of kind of finding out, whether or not it's a factor. We could then divide it out, factor it some more, throw down our zeros, look at the end behavior of the polynomial, and sketch out a quick little graph. Okay, we're going to end with this remainder theorem, and it kind of looks a little messy, but we'll break it down. If I have a polynomial, and I divide it by x minus k, I'm going to get a quotient polynomial plus some sort of constant remainder, some number. That number is actually equal to the the function evaluated at k. So in other words, here's another way to say it. If I want to evaluate a function at some number k, one other method I can use is to find the remainder of this division, the polynomial divided by x minus k, and I can use synthetic division in order to find the remainder. So here, f of 4. What's f of 4 of this function? Well, traditionally we would just plug in 4 here and kind of figure it out. The other way we can do it is we can figure out the remainder of this polynomial divided by x minus 4. And we can do that by setting up a synthetic division. So I put my k value right here. These are my coefficients here, and notice I stuck in an extra 0 here because we did not have an x term here. Run through my synthetic division, again, adding straight down, multiplying up here, 4 times 2. Adding down, multiply times 4. Adding down, multiply times 4. Adding down, this is my remainder, and according to the remainder theorem, that's the same as f of 4. So f of 4 is 122. And I could just double check if I wanted to on the side. F of 4 is equal to 2 times 4 to the third minus 4 squared plus 10 is equal to 2 times 64 minus 16 plus 10. And yes, indeed, that is equal to the same thing. So you see, this is bringing out the idea that there are two ways of evaluating f of 4. This is the new way where you can do this division and check the remainder. That remainder is f of 4. Okay, use the remainder theorem to evaluate these final two, and I will show the answer in 3, 2, 1. Okay, that's the lesson for today.